Hi, Doc Revis here with Watch Me Work It. Percent concentrations. Let's work some mass percent concentrations. Here's a problem. What is the mass percent of a solution of 5.2 grams of table sugar having a density of 1.59 gram per mil in 20.5 grams of skim milk having a density of 1.4 gram per mil? Oftentimes in problems like this, you'll have more information than you need at that time, but it might come in handy for some similar problem. So let's work this based on mass percent. So we know mass percent is like any other percent calculation. It's going to be the mass of the material in question. In this case, is sugar over the total mass, which includes the mass of sugar, times 100. And so if we look through our problem, we look for the mass of sugar. Oh, there it is right there. We have 5.2 grams of sugar. And we don't really need to write sugar, but I'm writing here to emphasize the point that this is the substance you're looking for. And the bottom, our total mass, bring it right down. You're going to see it beneath there, plus the mass of the skim milk. There we are, skim milk, plus 20.5 grams. So we have gram. We're good, times 100. And if you punch these numbers through on your calculator, you'll get 20% to 2 sig figs. You'll need to put a decimal point there to emphasize this 2 sig figs, or some like to write the number and put a bar above it to emphasize that it should be done to 2 significant figures. What is the mass percent of a solution of 5.2 grams of table sugar, density 1.59 gram per mil, in 20.5 mils of skim milk, having a density of 1.4 gram per mil? To do a mass, we need everything to be in mass. So we discover here that this skim milk is in mils. So we recognize at some point we will need to do a conversion. So let's just set up the original mass formula first. So we have mass. This is going to be mass, in this case of the sugar again, over the total mass, which includes the mass of the sugar. This is times 100. And so this is 5.2 grams divided by the grams of the sugar, which we know at 5.2 grams, but we don't know the grams of the solvent. In this case, the grams of the skim milk. So we need to find those grams. And that's the skim milk. So we can do that in a couple of ways. One, we can do the conversion by showing the mass equals D times V, which comes from the original density formula, mass over volume. So mass in this case of the skim milk would be 1.4 gram per mil, which is its density, times the volume that we have is 20.5 mils, and that will give us a value of 28.7 grams, which is what we need. Or we could do this by dimensional analysis. It would be 20.5 mils times bar 1 mil for every 1.4 gram. Run that through and we get the exact same number, 28.7 grams. So this is times 100 here. So let's just finish this problem by putting in all our values. You'll bring that value down in grams, 5.2 grams plus 28.7 grams times 100. If we punch these numbers through, we will get 15%. So there you have it, examples of mass percent concentration problems.